this lesson covers the C# operands and data types. So we've always said that the C# statements are made up of expressions terminated with semicolon, and that expressions are operands and operators. So operand and operator, they work on make up an expression. So we have looked at operator. So you could take a look at the various operators. Now we want to take a look at the operands and look at what makes up the operands, and also look at variables, what make up variables, how are they formed, and things that relate to them. We look also at constants, and then we look at the C# type system, looking at value type, reference type, pointer type, and all that relate to them. So at the end of this lesson, we should be familiar with the C# types and what do they do. So we said, so operands are memory locations containing data on which operators perform operations. So when we declare a variable or set up a constant, what we are telling the computer is we want to create a memory location that we want to put data in and access that data as necessary. That, in a nutshell, is what the operand are about. And when we consider operands can be either variable or they could be constant. So the key thing and why we're talking about data type in this video is that in C#, the type of an operand must be declared before it can be used, which means often before you can use an operand, before you can operate on memory locations, you need to declare the type. So the compiler must know the type and be able to deal with it. And of course, there are times when you might not know the type that will come in that we are going to use at runtime, but there is a presence of a variable type called the dynamic, which can be used to identify a time when variables are only known at runtime. So if we go to variables, so what are variables? Are memory locations that are given names through which it could be referenced and the content of which could change during the program execution. So when we set up a variable, what we are saying is we set up this variable, we make the variable available to be changed. So the variable can be changed during the period of the program execution. So whether we, so for instance, here we set up a variable location called A, and we put the value of 5 inside that location. Again, we put the value of 6 inside that location, and again we put the value of 7 inside that location. Again, we put the value of 8 inside that location. If we write out the content of that location, what should it be? It actually should be 8. So we can see it by looking at by actually checking it on the compiler. So let's check it on the compiler. So let's say we have a variable location. We do this. So if we run this code, we should see 8, which is, we can see that the value is 8, which is so we run this code, which we say, okay, set up a memory location, call it A, and then make the value to become B, 6, make the value to become 7, make the value to become 8, and then we write out the value, the content of the variable A. That content will be 8. So essentially, a variable, once you declare a variable, what we are saying is that the variable can be changed, and because it can be changed, every time we change it, the value changes as a result of that operation. So we say the value should be equals to 5. Then later we say the value should be equals to 6. Then later we say the value should be equals to 7. Later we say the value should be equals to 8. And once we do that, if we then write out the value will be 8, because the last change to the memory location is 8. So that's the thing about variables. So in defining variables, we actually must indicate the type of the variable and then the name of the variable. For instance, when we say int a, what we are saying is we are creating an integer value, an integer memory location, and we are saying that that integer memory location should be set up. And then, so to do that, we need to give the type, which is in this case is integer, and then the name of the memory location in this case it is a. Again, another example is if we do something like say int age, what we are saying is that we set up a memory location called an integer, and we call that memory location age. So that is called defining a variable. Another thing we now want to look at about is initializing a variable. Initializing a variable actually means putting a value there. In our defining a variable here, this value will contain the default value, which will be 0 for integer, or it will be null for an object if we just define it without assigning any value to it. So initializing the variable means making sure that we put an initial value in that variable, and you can do that by carrying out this same step. So I can come out and say int age equals 25. So I can do this. Once I do this, I'm both defining and initializing this variable at the same time. And there are certain rules that relate to the C# variables, the naming, how to name it. You cannot simply start the name of variable with an integer. It's got to start with an alphabet, and then you can then append an integer to it. But you can't do something like say a equals 5 or whatever, 5a as an integer. That will not work. So assigning a value to a variable, you assign a value to a variable by using the assignment operator, which we have learned about already. So in this case, we say a is equals to 6. So a is equals to 6 means we assign the value the value 6 to the memory location a, just like we did here, and we demonstrated it on the compiler. That is that with a variable. So in C#, the operand is either a variable or a constant, and so we have looked at a variable. Now let's look at still looking at variables. C# expressions can either be L values or R values. So R values are values that can be allowed to be on the right-hand side of the assignment operator, and L values are values that must be on the left-hand side, that are allowed to be on the left-hand side of the assignment operator. What I'm saying about is this. So in this case, A is an L value, A is an R value, and A is an L value, and 5 is an R value. The one on the right-hand side is the R value. The one on the left-hand side is the L value. For instance, if we try, okay, let's even take this to the compiler and try to see what type of error is going to give us. So if we do this, and we go to the compiler, to our online compiler that we'll be using, if we put this value, if we do this, so if we try to run this thing, we find an error here So it says the left-hand side of assignment must be a variable property of indexer. That's the thing. So the issue of head value is very important. So head value is, this is permitted, and a variable can be there, but I mean, like an integer cannot be an L value. That's exactly what the compiler is telling us in this case. So that's exactly what we're talking about. So we need to understand the difference between L value and R value and know what value go to the right-hand side of the assignment operator and what values go to the left-hand side. But most the clear things are variables are allowed to be on the left-hand side, and you cannot put constants on the left-hand side of the, after defining it, you cannot put it there on the left-hand side anymore. But at the point of definition, that is possible. Another thing that we often do with variable is you could get value from the user. You could get value from the user and do something with it. So usually now, if you want to read the value, mostly on using the console, you use the console.readline. Console.readline. The console.readline has a number of different flavors. But let's run this code and let's run it on the compiler and see exactly what happened. So we are going to run. I'll just uncomment it here. So what we are saying here is we have on line 15. We have on line 15 is console statement that says console.writeLine, please enter your age. And then on line 16, which is the core line that I want to draw your attention to, we have int age is equals to convert dot to int 32, then console.readline, then semicolon. And then we have console.writeLine, which you are familiar with. But we have a concatenation here, taking this variable that we have initialized here, and then taking that variable and then outputting it out in line 17. So let's run the thing. So the thing on running that code is prompting me to enter the age. So I'm just going to say, let's say 30, and then we just press enter. And it comes out to say you are 30 years old, which is exactly what we want the system to do. So we say to prompt and ask for the age, and once we have entered the age, it should store it in a particular location called the call age, and then thereafter it should output the content of that memory location, which is exactly what it has done. So in this case, what we have done is to use a variable called age to store the value of age. So in this context, you will see that we have spoken with the user. We told the user exactly what we want the user to do. And after the user did what we want the user to do, we carried out a simple operation on the data that the user supplied, and that essentially is using a variable in that context. So let's go to constant. So like variables, constant are memory locations with values that may not change during the period of running the program. So what we are saying is we set up a memory location and we put a value there. And if we thereby come later and try to do something with that value, we will not be able to do that. The compiler will give us an exception. Let's see that in actual implementation. So let's say, so if we comment out this, and we comment out this, and comment out this, and then we put this one there. So constant is equals to 5, and then if we come back. Okay, so we already have here. Let's do that. So let's see what they said. It said the left-hand side of an assignment must be a variable. So we cannot, once you declare a constant, you cannot access that constant again, as you cannot use that constant again as the left-hand side of an assignment. That's exactly what we're talking about when we talk about the L value and the R value, and the fact that knowing the L value and R value is important. So also, so once you declare a constant, you can use it just like a variable. You can use it just like a variable. You cannot change it. So that's the only difference between a constant and a variable. And yeah, there are several system-defined constants that we make use of in C#, and some of them like new line, return, tab, and other things like that. These are constants that are predefined and they are available for use. So once constants are declared, the values are not allowed to change, as we have seen. So, but as we have also said, we know that constants and variables, their values must be declared and known before they can be used. So that takes us to the type system. The C# type system, there are three major types in C#. So when you are going to declare either your constant or your variables, there are three major categories of type that it could be of. The first type is the value type. The value type are used for simple. They are used for simple data. They are used for simple data that will not be, that will be maximum of around 16 bytes of memory location. You use value type for that. But for large data, like you are trying to store a picture, or you are trying to store a database value, or you are trying to store a document, we usually use the reference type for it. And then there's another type called the pointer type, which are actually regarded as unsafe types, because they are used. When you use the pointer type, you are dealing directly with memory location. Whereas in the .NET system, the system handles memory allocation and deallocation through what is called garbage collection. So you are not expected to now start going there. So that you can still do that when you want to do high-level things that you don't have libraries available for, you use pointer type. So, but the value type is made up of three major types. We have the simple type, which are like the Boolean. The Boolean are the true or false. The character variables. So the character variables. We have the integer variables such as int, and then we have the bytes, which are also like integer, and then we have the floating point, which is like when you are trying to do something like 3.1757, which is pi. You store that because of the point, decimal point that's involved. And when you are trying to store large amount of data, which involve numerous decimal places, then you use things like double, and of course we also have decimal there. So these are value types. Value types are for simple data types, data that will not take more than 16 bytes. So 1 byte equivalent to about 1 character of storage. And reference types. So apart from simple type, we have the enum or enumerations. These are user-defined types that you use to store different category of information. And then we also have structures. So these are all value type, and they can be stored on the. I will talk about the differences between the reference type and the value type presently. Just immediately after this slide, I'm going to talk about that. So the reference types are for They are usually mostly user-defined types, and they are for storing large volume of data, so that when you need to store things like picture, or you need to store things like video, or you need to store files, you begin to use classes and things like interfaces, and we also have arrays and delegates. These are all reference types. So, and then of course I've talked about the pointer type. So the thing to know about all of these types is that all these types are compatible with objects. All these types are compatible with objects, and because they are compatible with objects, all the operation that can be performed on object can be performed on them, and they have all the attributes of objects. So that is the thing about the unified type system. That's the thing about unified type system. So when we use this type to declare our variables and to declare the memory, to tell the system what we are going to store. What is the difference between the value type and the reference type? The value types are usually values, whereas the reference type contains reference. So the difference between value means if you want to store 5, then 5 is what is stored in the memory location. Whereas a reference type will not store, if you want to store a picture, it will not store that picture at the memory location. It will only store the address of that picture, which is called the reference. So that's the difference between the value itself. So you store 5, or you store the address of the value. So when you store the address of the value, we are talking about reference. And also the place that the thing is stored on the computer is different. In the computer, we have two types of memory. We have the stack, and we have the heap. The stack is like a last in, first out part of the memory, and the heap is like is the first in, first out huge chunk of memory containing most of the data on the computer. So lightweight materials are stored on the stack, and heavyweight materials are stored on the heap. So the heap memory is a huge chunk of memory containing the entire system, whereas the stack is the place where we store lightweight information. So value types are stored on the stack, and the heap, and reference types are stored on the heap. The initialization, for when the value is not initialized, the default value for value type is actually either 0 or false, or almost null 0. But for the reference type, the initial value is null, and then that's the initial value. So when you assign values to the reference type, what you do is you copy the value into the reference, into the value type. You copy the value into the location. But when you assign value to the reference type, what you do is you copy the reference. So you don't copy the value. There is a picture here indicating that. So for instance, when I copy, if I do integer high is equal to 17, if I then come back and create another integer and call integer j, and I say j is equal to high, what will happen will be that 17 will be copied into j, so that we will have 217. I will have a 17 in high, and we have another 17 in j. But if I'm using if it's an object, I declare a string and call it, say, hello. If I declare another string number 2 and I call it s2, and I put the value in s1, in s2, the system will not copy it will not copy the value and create 2. It will only copy the reference, which is the memory location address to hello, and store the reference. That's the difference between these are the differences between the value system and the value type and the reference type. So we use the value type for lightweight data, and we use the reference type for heavyweight data. You can see the advantage of doing that here, which is that once you remove, you don't carry the baggage of a huge and have duplication of a huge amount of information, which will have been what will have happened if we don't have the reference type system. So the value type, we have the simple type, which we have talked about, and then we have the enum, and then the struct. These are all user-defined type, and of course we have the reference type are classes, interfaces, dynamic type, array, and delegate. We are going to be looking at in subsequent classes. We'll be looking at this other type. And of course, before we go, the simple type. So if we look at the simple type, we have the byte, the short int, we have the uint, which is unsigned int, we have the long, and of course the range of value that you can store there. So if you declare a value, you cannot go in and store more value than necessary there. So let's do something. And first thing we'll do is let's try to get this the long form of a type. To do that, we will use the type of operator. If you watch the video, the latest video that I posted today on type, you should see the type of operator. I've done a revision on that. I encourage you to watch it, which is the video on the revision of operator. So if we do type of operator, if we do this and try to undo this, we should see the type. So if we run this code, so the size of int is okay. The type, so the type of this should be type. So the type of int is, so if we do that, the type of int is 32. If we can also check other things. Let's say float. If we want float, so this will be float. If we run this code, is system.single. So we have system.single. If we do double, so in this way we're able to actually find out the long form of any particular type that we're interested in. Of course, you can also get the size of the permittable size of any of the types. So that in a nutshell is an introduction to the type system. From after this time, we'll be looking at the enumeration type. We'll be looking at structure. We'll be looking at classes. We'll be looking at delegates and how to use them in C#. So do we have any questions? Do we have any questions? If there are not questions, or if you prefer to speak with me one-on-one, that's allowed. I will be available for at least about 20 minutes after this class online to speak with you in case you really want to speak with me on that.